Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how you can get hull information and form from Orca3D and use it as input into a seakeeping analysis in ProteusDS. So Orca3D is a series of functions and capabilities that adds an enormous amount of naval architecture design capability to the Rhino platform. So here I've got Rhino 8. And you can see with Orca3D added, you get a new menu here on Orca3D. And what I really want to talk mostly about today is the hull assistant. So if we go hull design and then hull assistant, and then I'll go to ship assistant and go to default, open assistant here, and click on preview hull, you'll see that we have a hull form that appears in Rhino. And what's really great is there's a number of adjustments and parameters you can slide and adjust on the hull form. Many different parameters on the shape of the hull and the bow form factor and things like that, if there's a bulb or not and everything. I don't want to focus on the details today. We'll expand on that in another video tutorial, but what I want to talk about is the basics. So how do you get information from your hull form into ProteusDS for a seakeeping analysis? The main thing to focus on here is we want to get the right reference frame orientation and get everything set up within Rhino as much as we can. So the first thing to note is by default, the orientation of the frame is different. What we want to generally do to make things smooth for setting up a seakeeping analysis is have the aft perpendicular at the origin in Rhino with X positive towards the bow, and we want to be looking at the positive coordinates of the hull form, so it's going to be the port side. So the first thing we're going to do is actually just close this and then go to Orca3D, and we go down to properties, and then the model orientation you want to change forward as -X to +X, and go OK. There's another message that comes up. So now when we go to Orca3D and hull design and hull assistant, we'll go to ship assistant and open this again, preview the hull, and things are looking much better. Now the other thing you're going to need to do is just double check the offset. I was working with this before. I think I already had added an offset equal to the length of the ship here, but for each ship that you design, if you've got a length of 160, you'll just need to double check that you, when you shift the origin, you've made sure that that's shifted off the origin the correct amount. So maybe we'll change this to, say, 100. And really what we want to do is have this reference frame 100 forward of that. So we'll go shift origin, and it says select location to shift origin to. So what I'm going to do is type in 100, 0, 0. There. And I think you get the general idea. It doesn't have to be laser precise, but it'll just help when you're adding information like hull appendages in for the hydrodynamic model in ProteusDS later to have these things lined up as best as they can be. Okay, and then now the other thing you want to do, of course, you do have a displacement here that will provide some analysis capabilities within Orca3D, but for the purposes of incorporating the mesh into the seakeeping analysis, what we want to do is set the draft to 0 here. And when we do that, it's moved the baseline along the Z plane here, and you want to do that in preparing a mesh here for seakeeping analysis. Now the last thing you want to do is make sure you're only doing the port side. So when we go to create, we go create port, hull, deck, and transom, and here's our geometry. Now we need to make a mesh from this, and so we can do this relatively quickly in Rhino using the quad remesh command. So you can select all of these together. This is a NURB surface, and what we'll do is go quad remesh. 2000 might be too many. It really just depends on the ship and the hull form and how you want to replicate the geometry here. We'll want to go preview, hide input objects. Usually a symmetric axis on X helps a lot. Well, in that case, it didn't help very much. that looks reasonably good. There's kind of a lot of detail back here though. Maybe we will reduce this a bit and see how that works. That's better. All right. Anyway, this is meant to be kind of like a rough guide on getting things oriented correctly. So we'll delete the input objects as well. That'll get rid of the NURB surfaces. Go OK here. So there's our resulting mesh. The way that I've configured Rhino is to make sure the normals are oriented the correct ways. I've got red on the inside. That's the backface color. There's another video tutorial on that which might help you. Now what we want to do is we're going to save as. And we'll go, for now I'm just going to save this on my desktop. Where's my OBJ mesh? We'll call it hull 100 meters for the length. And everything is good. We'll go OK. Now I'm going to minimize this for now. Then we'll make a new folder here on the desktop. Just to hold our ShipMo3D toolset project. So this is now going into ProteusDS ShipMo3D toolset. First thing we'll do is pick our brand new folder, vessel project. And oh, yeah, ship length between perpendiculars. It's already got 100 meters. Looks good. All right. Mainly, I just want to show what it looks like when we import the hull. So we'll go add new data, panel hull, and we want to change this to wavefront OBJ. And what we want to do is, well, ideally, I want to copy and paste this into my vessel project. So we'll just go copy that there. Pick the hull that's in there, just to keep it organized. We'll go run. And now when we plot panel hull, I know something we forgot to do. We forgot to set the displacement. So the draft of baseline at midships, I'm just going to pick a value here of 5. Run that again. So we got plot panel hull and go ship parts. Now we have the yellow part showing as the displacement. So remember when we bumped the hull orientation, so the baseline was at the Z plane. The reason for that is because we may be changing the displacement when we're doing the hydrodynamics analysis. And with a 5-meter displacement on this 100-meter long hull, you're seeing the yellow form here is the wet hull, and there's some automatic mesh refinement along here. So, you know, ahead of doing this analysis, you may realize, oops, I meant to do 8. Rerun this again. And so you'd be adjusting that displacement. I really like the ship parts because it just very clearly shows which is the wet hull here. So this is the first stage in doing a hydrodynamic analysis. The point of showing this was to kind of just highlight how you can leverage that really interesting capability, Hull Assistant in Orca3D, and come up with really different kinds of hull forms, and then how do you get that information into ProteusDS ShipMo3D toolset for a hydrodynamic analysis, which we showed here. All right, that's all for now. Thanks for watching.